Greetings once again, students. Welcome to another video from iCampSA. In this video, we're going to be doing a past paper. This one is from 2018. It's from 2018, and it's the area of focus is once again functions. Let's get into it. Okay, so for question 5, sketch below are the graphs of f at x is equal to ax squared plus q. Ax squared plus q, what does that tell us? We are seeing something we are familiar with. Ax squared plus q, it means we are dealing with a parabola, the parabola. And as we can see from the sketch that the function, the parabola, is facing downward. It means that the value of a is gonna be negative. It's gonna be negative, and then let's see, it's gonna be our value of q, and then g at x is equal to negative half to the power of x minus 4. What is that minus 4 that we have there? That is our horizontal asymptote, so it's going to be the value of this. Okay, and then we are told that a and b are the x-intercepts of f. A and b are the x-intercepts of f. The graphs intersect at a and point E. Okay, they intersected A. Okay, and then point E, 1 and 3, which is 1 and 3, lies on F. The parabola C is the turning point of F, and D is the y-intercept of G. Okay, so that is what we are given about these functions. Let's go ahead and see what the questions have for us. So for 5.1.1, we are asked to write the coordinates of D. What is D? D is the y-intercept of the function of g at x. So for 5.1.1, we are dealing with the y-intercept. So let x equal to 0. That is how we go about answering or solving for the y-intercept. So g at x is equal to g at x is equal to 1 over 2 to the power of x minus 4. Double check. Yes. So we are looking for the y value where x is equal to 0. So g at 0 is going to be 1 over 2 to the power of 0 minus 4. Therefore, g at 0 is going to be 1 over 2 to the power of 0 is 1. 1 minus 4 will be minus 3. Therefore, the coordinates of D are going to be 0 and negative 3. 0 and negative 3. That's the coordinates of D. And then next, we are asked to write down the range of G. The range of G, okay, this function, as we can see that the function only exists above that horizontal asymptote, so it exists for all the y values except right up until we get to the y asymptote. And I said that the horizontal asymptote is given by y is equal to negative 4. So the value there is negative 4. So for our range, we're just gonna say 5.1.2. For the range, we say y is the element from what? Round bracket negative 4 to positive infinity, round bracket, because the negative 4 and the infinity are not included. Or we could have just said y is greater than negative 4. Both are correct. Whichever one is easier for you, you can use. Okay, and then for 5.2, calculate the coordinates of A. What is A? A is the x-intercept of G. So we can just use that in order to find the coordinates of A. This is 5.2.1. 5.2.1. We are saying A is x-intercept of G is x-intercept of G. So that's what we're gonna use here. So and then for x-intercept, let me use a different color, saying for x-intercept, let y equal to 0. Okay, that is how we solve for a x-intercept. So g at x is equal to, what is the equation for g? G at x is equal to 1 over 2 to the power of x minus 4, and we are saying we let y equal to 0, so this is going to be equal to 0, equal to 1 over 2 to the power of x minus 4. We take the minus 4 to the other side, so we're going to have a positive 4 is equal to 1 over 2 to the power of x. Okay, 1 over 2 to the power of x. Let's try to express 4 in terms of 1 over 2, so that we can have the same base, and we use the laws of exponent to drop the bases. So we're gonna have 1 over 2 to the, what are we looking for, the x-intercept, to the power of negative, it's gonna be negative 2 is equal to, it's gonna be negative 2 or 1. Let me quickly double check. So 1 over 2 negative 2, yes, it's gonna be negative 2. Yes, it's gonna be negative 2. Gonna have 1 to the power of x, so we can drop the bases. Therefore x is equal to negative 2. X is equal to negative 2. What were we looking for? The coordinates of a. The coordinates of a. Therefore a has the following coordinates: negative 2 and 0. Negative 2 and 0. That is our a. Okay, and then next, for 5.2.2, we are asked to calculate the values of a and q for the parabola. Now the values of a and q. Okay, q is a, what is the, q is the, what's it called, this thing, the turning point and the y-intercept, and then we have a, but we have 2 points. We have now, what is this, a, which is negative 2 and 0, and we have that coordinate which is 1 and 3. We can just use those coordinates and solve for a and q, since we have two unknowns. This is 5.2.2. 5.2.2. Okay, so for 5.2.2, what is the f function? F at x is equal to ax squared plus q. Ax squared plus q. Yes, and then we substitute the coordinates that lies on the function. First, coordinates number a, which is negative 2 and 0. So 0 is equal to a into negative 2 squared plus q. Let's make q the subject for this one. So therefore q is equal to a negative 2 squared is going to be a positive 4, so it's 4a, so it's going to be a negative 4a, since we're going to move it to the other side. And then the other one, let's use the coordinates of e, 1 and 3. So we're going to have, or we can say this is equation number 1. For equation number 2, we use the coordinates of 1 and 3. Y is equal to 3. A coordinates of x is 1 squared plus q. Here we're gonna have 1 squared is what? Is just 1. So we're gonna have a plus q is equal to 3. So we can make a the subject here. We can say a is equal to 3 minus q, 3 minus q. This would be equation number 2. And then what do we do next? We sub equation 1 into 2 in order to solve for a. Okay, so we're gonna have a is equal to 3 minus, what is the value of q, minus 4a. Okay, a is equal to 3 plus 4a. 3 plus 4a. I'll put the a's on the one side. We're gonna have a minus 4a minus 3a is equal to 3. We divide by 3 on both sides, by negative 3 on both sides. Therefore, a is equal to negative 1. A is equal to negative 1. We can substitute that to find the value of q. Q is equal to negative 4 multiplied by a, which is negative 1. Therefore, q is equal to negative 4 multiplied by negative 1. We're gonna have a positive 4. A positive 4. And remember that q is our turning point. It's that turning point of this function. Yeah. Okay. Next, we also determine the length of CD. The length of CD. Okay. We have the coordinates of C, which just calculated. The turning point is what is 0, and what is the value of Q? The value of Q calculated is 4. And then the coordinates of D, I believe that is what we calculated. The very beginning is 0 and negative 3. 0 and negative 3. Okay. Therefore, we can use those to calculate the length of CD, because CD is just a vertical line. So for 5.3.1, 5.3.1, we're gonna say CD is equal to y of C minus y of D. What is y of C? Is 4 minus y of D, which is negative 3. Quickly double check. Yes. Okay. Therefore, 4 minus 3 is gonna be 7 units. 7 units, and that is the length of CD. Okay. And then next, we are also calculate the equation of the straight line through A and D. So it's gonna be a straight line that goes through A and D. So a straight line of this nature through A and D. Okay, so we have two coordinates, and that's all we need in order to calculate the equation of a straight line. Okay, let me quickly edit the page, as I saw that we are running out of a page. Okay, so this is 5.3.2, the equation of a straight line through A and D. Let's quickly write down the coordinates of A and D. Coordinates of A is negative 2 and 0, and the one for D is 0 and negative 3. Okay, this is 5.3.2 is 5.3.2. Coordinates of A is negative 2 and 0. Coordinates of D is 0 and negative 3. Okay, so first thing first, we need to calculate the gradient of this line, which is our m. The gradient is the difference of the heights over the difference of the run. So we're gonna have y2 minus y1 over x2 minus x1. So looking that the line goes through A and D, it's gonna have a negative gradient since it's a decreasing function. You can see from that line that I've sketched there. Okay, so y2, let's take D for y2. So we're gonna have negative 3 minus 0 over over x2, which is 0 minus 2. Therefore the gradient is negative 3 over 2. Negative 3 over 2. Remember that the general equation of a straight line is y is equal to mx plus c. Next, what we have to calculate is the coordinates of c, which is the y-intercept, where x is equal to 0. But here we know that the equation passes through what? Passes through the point D, and D is essentially our y-intercept. So for the value of c, it's gonna be just c is equal to negative 3. C is equal to negative 3. But for those of you, let's say you happen to forget that c is equal to the x-intercept, what you do in order to find c, we can take any of the coordinates and solve for the value of c. Let's also do it with that method. Let's take coordinate a. Coordinate a, we have 0 is equal to, what's the value of m, is negative 3 over 2 multiplied by x, which is negative 2, plus c. Negative 3 over 2 times negative 2 is just going to be a positive 2. We take it to the other side. C is equal to negative 3. Here we said this is the y-intercept. Okay, so you see that you get the same answer. Therefore, the equation of the straight line is going to be y is equal to negative 3 over 2 minus negative 3 over 2x minus 3. Okay, that would be the equation of your straight line which passes through A and D. Okay. Next. Okay. For which values of x is f at x greater than 0? F at x greater than 0. So for all the values of x greater than 0. So let's use the graph. It's the parabola that we are looking at. So basically, when we are asked to find determine the values of x whereby our function is greater than 0, where is our function above the x-axis? Where it is above the x-axis, so it's from a to b. That is where our function is above the x-axis. So from negative 2 to what? What is the value of b? Is 2 and 0, the coordinates of b. So the x values where x is greater, where x is greater than negative 2 but less than 2. So for all those values, okay, that is 5.4.1, 4.1. We say where x is greater than negative 2 but less than 2. For all those values, that is where the function of f at x will be greater than 0. And then next we are asked to find where the function of f is decreasing. Remember, we said for a function to be decreasing, or how do we determine whether a function is decreasing or increasing? The function is decreasing if, as the x values are increasing, the y values are decreasing. Now let's come here. As we go from here, negative infinity, up until x is equal to 0, what's happening? The x values are increasing because we are moving towards the y-axis, or we are moving from the left to the right. We know that the x values are increasing in that direction, but also as we are moving from down to up, the function is what? The y values are increasing. So as we move here like this, both the x and the y values are increasing. So this side is increasing. But once we get there and x is equal to 0, what happens? As the x values are still increasing, what's happening with the y values? The y values are decreasing. So our function from x is equal to 0 is doing what? is decreasing. So we're gonna say for 5.4.2, for 5.4.2, where x, saying where x is greater than 0, that is where our function would be decreasing. That is where our function would be decreasing. And that is how you'll go about answering 5.4.2. Okay, so it's last question in question 5. Let's go ahead and do question number 6. Okay, so for question number 6, what do we have here? The equation of the function g at x is equal to a over x plus q, a over x plus q. What do we see here? We see x in the denominator, which means we are now dealing with a hyperbola, and that plus q there is our asymptote, is the horizontal asymptote. Passes through the point 3 and 2 and has a range of y is the element of negative infinity to 1 union 1 to positive infinity. And from the range we can determine that there is that value where our function doesn't exist, and that value is what? Is 1. So it tells us that that 1 is essentially our horizontal asymptote. And what is represented by the horizontal asymptote in the equation is that value of q. So we already have the value of q, we have the coordinates, we can determine the equation of g, which is question number 6.1.1. So for 6.1.1, we are saying q is equal to 1, reason being horizontal asymptote. Okay, and then let's go ahead and find the equation. It passes through point 3 and 2, so g at x is equal to a over x plus 1. Let's substitute the coordinates of 3 and 2. So 2 is equal to a over x over 3 plus 1. Let's solve for a. Take the 1 to the other side. It's gonna be a over 3 is equal to 2 minus 1 is 1. 3 multiplied by 1 is 3. Therefore a is equal to 3. And look what we have here. A is positive. So a positive a means what? Means that the branches of this function will be in the first and the third quadrant. Okay, but let's quickly write down the equation that we were asked to find. So g at x is equal to 3 over x plus 1. That is the equation of g. Okay, and then from there, equation of h, the axis of symmetry of g, which is a positive gradient, So remember that the equation of symmetry is either y is equal to x plus or minus the gradient for the one with the positive gradient. So plus or minus the asymptote, the value of the asymptote, and the one from with the negative gradient is always going to be y is equal to negative x plus or minus q, the asymptote. So for 6.1.2, the equation of the asymptote is going to be y is equal to x positive gradient plus 1. That plus 1 is for what? Is for the asymptote. Okay. And then for 6.2, we are to sketch a graph of g and h on the same system of axes. Clearly show all the asymptotes and intercepts with the axis So we are sketching now for 6.2. 6.2. Let's start by drawing our axis. 6.2. Okay, so for 6.2, calibrate our axis. Calibrate 1, 2, 3, 4, 5, 6, 2, 3, 4, 5. So we're gonna have -1, -2, -3, -4, -5. We're gonna have 1, 2, 3, 4, 5, 6, 2, 3, 4, 5, -1, -2, -3, -4, -5. Okay, let's sketch our function. We start with the asymptote is that y is equal to 1. So our asymptote will be here. Y is equal to 1. Y is equal to 1. Okay, clearly showing all the asymptotes. And for this function, we're gonna have an x-intercept. Let's quickly calculate the x-intercept. The x-intercept, the equation of the function, okay, for x-intercept, let y equal to 0. What's the equation of the function? G at x is equal to 3 over x plus 1. So we're gonna have g at x is equal to 3 over x plus 1. G at x is gonna be 0, is equal to 3 over x plus 1. Therefore x, we're gonna take that 1 to the other side, so we're gonna have a -1. Therefore x is gonna be equal to -3. That's the x-intercept, and that's the only intercept we're gonna have here. And the function, the value of a is positive, so the function is gonna be in the first and the third branch. So the function will be like that. This will be the g function. This will be the g function. The intercepts here is -3 and 0. Okay, let's quickly write down, draw the equation of h, sorry, the function of h with the positive gradient, which passes through 1, What's the equation of h? Y is equal to x plus 1. The x-intercept is gonna be at negative for the equation of h, so we can also calculate it here. Say h at x, the equation of h at x is x plus 1, but it's gonna be at -1. For the x-intercept, it's gonna be at where y is equal to 0, therefore we're gonna have x plus 1, therefore we're gonna have x is equal to -1. X is equal to -1. That will be the x-intercept right here, and it passes through 1. Therefore the function of h is gonna be of this nature. Function of h, yes. Axis of symmetry of the hyperbola. This one is h at x is equal to x plus 1, and this one is g at x is equal to 3 over x plus 1, and then the intercepts -1 and 0. And that is how those two functions are going to come out. This is 6.2. And then let's go to 6.3. Write the equation of the asymptotes of f if f at x is equal to negative g at x plus 5. Okay, the equation of the asymptotes of f. So the function of f is negative g at x plus 5. So it has been reflected. It has been reflected about the y-axis, and it has also been shifted. It has also been shifted 5 units upwards. So 6.3. So we have been given that the function of f is gonna be f at x is equal to negative g at x plus 5. Let's start finding the equation. Let's start by finding the equation of f, which is gonna be negative into 3 over x plus 1 plus 5. Therefore f at x is equal to negative 3 over x minus 1 plus 5, of which will be f at x is equal to negative 3 over x minus 1 plus 5 is gonna be a positive 4. And then for this function, the equations of the asymptotes are gonna be y is equal to 4, which is our horizontal asymptote, and then x is equal to 0, which is our vertical asymptote, Okay, and that is how you would go about answering that question, question 6.3. Okay, and this, I believe, marks the end of this video. Until we meet again, I wish you good luck and good studying.